Every time. Hello, testing, 1, 2, okay. So good afternoon, ladies and gentlemen. My name is Jason Becker. I'm with Weld.com, and I'm honored to be here with Sam Hackman, one of the ESAB Elite. So today we're going to be talking about the AWS D 1.1 structural test for shielded metal arc welding. So shielded metal arc welding, if you're familiar with the code book, it is a pre-qualified process, and the positions we're going to be going through are pre-qualified procedures. So that means you don't have to get these qualified on your own. Okay, if you go through the D11 code book and you get your fit up correct, you use the appropriate process with the appropriate amount of amps, and it's going to give you repeatable results. Okay, that's what we're looking for when we talk about pre-qualified. That's one of the reasons anybody do short circuit MIG welding. It's one of the reasons that it's not pre-qualified, because it is not repeatable. You know, probably if a bunch of people ran that same exact test, only a few of them might pass because it's prone to lack of fusion. That's why you have to actually qualify that. So how many of you are welding students? Perfect. So this is probably a test very similar to what you're going to have to take in school, right? There's a big misconception with welding certifications, qualifications that you earn in those programs. Okay, those qualify you to weld while you're in school. But once you leave and you get out into employment, you go out and find a job, the employer is responsible to test you. Now a lot of them, they say, you know, they want to hire you, you have to be certified in order for them to hire you. That's a big misconception. It says right there in the code book that it is the manufacturer or contractor's responsibility to qualify and certify all of their workers. So if I go to a school and I take the test and I pass the test, good on me. That shows a level of proficiency. It does not mean that I can go work for a company over here and start putting up high-rise buildings, okay? It's their responsibility. They have to develop a welding procedure specification. They have to have a PQR, which is a procedure qualification of record, and then they have to certify you to those standards, be it by X-ray or by bend test. Because these are pre-qualified, they can use one of the two. For short circuit MIG, they have to pre-qualify that one, or they have to qualify that one with a bend test. Tensile pulls, X-rays, there's all kinds of stuff to do that with. So today what Sam and I are going to show you is a standard test plate with backing, because it is a structural code for steel buildings. So there's not much open root. If there is, it's usually back gouged, and then you grind that out and then you fill the backside up. So it's called a full pin weld or 100% penetration weld. Essentially it's just a couple of, we have two 3-inch by 6-inch pieces that are beveled to 22.5 degrees for an included angle of 45. So the angles that these reach in between both of them are a 45-degree angle. Now AWS gives you quite a bit of variance. Right now we have about a 5/16 gap. You're allowed 3/16 gap up to 9/16 with the tolerance that they give you. And with a 22.5 degree angle for 45 degrees, I think it's -5 and +10. So I can go from 40 to 55 degrees for my included angle. So there's a little bit of room, for tolerances when you're fitting these up and getting them all set up. So we're basically going to demonstrate a root pass, hot pass, fills, and caps in the 3G position and 4G position. So because of the thickness of the material, Sam and I are going to kind of alternate. What I like to do is run a root and a hot pass. I let that cool down for a couple minutes, and then I'll start running my fills. So Sam will start off with his root and fill. Once he's done with that, I'll go through, I'll run my root and fill, or I'm sorry, root and hot pass. He'll start on his fill passes, then I'll do mine, and then we'll just alternate back and forth, and we'll kind of give you guys little techniques. I'm sure Sam welds a little bit different than I do, so we're just going to show you two different techniques, and then we'll talk about the final bead appearance once we're done and the acceptable criteria for that. Sound good? All right. Do we have any welding instructors? Anybody that teaches welding? Okay, so one thing I used to do with my students is I made them do a stop and start in the middle of the test plate or somewhere along the way. It's not required, but it's definitely builds confidence and it builds proficiency with the welder, because if anybody's ever welded before, you know you're going to have to do a stop and start at some point, whether you like it or not. I like to stop on my own terms, so I try not to burn that rod all the way down until there's nothing left. What I'll typically do, I'll get to a good point where I feel like it's a good stopping point, and I will whip out really quick. What that's going to do is that's going to give me a nice little crater. I want that crater to where I'm going to do my tie-in, because if I slow down, now I'm going to have a lump in there. and if I go to retie into that, I'm going to have a cold start. So what I like to do is just whip out real quick, leaves a nice little crater. I've got a good spot to tie into. That's up to the instructor, the instructors, however you guys want to do that. That's just something that I did, and like I said, it builds confidence, helps them out. So it's just a good concept to try to enforce with them. Yeah, as long as they don't do it right in the testing area, but it's up to them. I said you just have to shoot it somewhere in there. Now, if you'll notice, you can go ahead and run your route. If you notice, we have the backing strip here is a 1/4 inch by 1 inch. So this would be set up for a bend test. Okay, we actually put a couple tack welds on the back so that once you're welding this up, that it doesn't curl up too much, because heat's going to move metal. So this is set up for a bend test. Now, if we were going to set up for a radiograph test, I would use a 3-inch wide piece. Okay, so instead of 1 inch wide, I would use 3-inch wide, and that's basically so the radiographic tech is examining this. The tack welds that I use to hold this plate in place, they're not going to show up on radiograph. It's going to show up outside the welding area. So make sure if you're going to send it off for RT, don't use a backing setup like this. Okay, switch over to a 3-inch wide. I'll get out of y'all's way so you can see it. So he's using like a little side-to-side movement. You want to go nice and slow. You want to fill that up and tie into both of these edges here, okay? You want to try to make it as uniform as possible, because you're building the foundation for all the subsequent passes. So when he puts his root in, he's laying the foundation for his hot pass. When he puts the hot pass in, he's laying the foundation for the fill passes, so on and so forth. Did they get us the chip and hammer? Okay, cool. The plate cannot be too clean. So when I start off welding, I make sure the plate is nice and clean before I start striking an arc on there. Take all that mill scale off, clean it up nice and good, and then start welding on it. In between your passes, you want to make sure that there's no slag in there. So if you have access to a dental pick set, you can pick them up at most automotive stores, but get a little dental pick set, and you can pick out any small slag. Now with D11, they don't restrict you to tools. So it doesn't say that I can't use a grinder to clean that up. But I tested my students under D15, which is a structural steel bridge code. You cannot use power tools. The only thing you're allowed to use is a chipping hammer, wire brush, file, chisel, and a hammer, hand tools. And then once you're done, there can't be any tooling marks on the surface of the plate or the weld. So you really have to know what you're doing when you go through the test. And once again, it just builds another level of proficiency and confidence with the welder. A lot of times you can't get a grinder where you need it. Now you'll notice that the backing strip is approximately 1.5 inches longer on either side of the plate, and that's called a run-on and run-off tab. This is the area that I start with. I don't want to start my weld dead center at the beginning of that piece, and I don't want to terminate at the very end of this piece, right? I'm going to start prior to, and I'm going to weld up into that joint, and once I reach the top, I'm going to weld past it. And that's because in the field, I would then cut those run-on and run-off tabs off, and then just hit it with a grinder really quick just to clean up the edges, and those pieces would go away. Okay, but what that does is that allows me to know that everything's running good before I get up into that joint. And because the weld profile has to be flush to 1/8 of an inch above the plate. So for 3/8 material, that weld's allowed to extend 1/8 above this plate. Okay, once you get into 1-inch plate, I think you're allowed up to 3/16. So that run-on and run-off tab, that allows me to build up weld profile at the very beginning and the very end, so that I don't have any low spots in there. If it's low, it's going to fail the initial visual inspection. Before this says sent off to RT, radiograph, or X-ray, or before it is bent, it has to be visually inspected. Okay, and you can't have any low spots. It has to be flush to 1/8 inch above. Happy with it? You can go ahead and run the hot pass.
What's that?
You want to go ahead? All right. All right. So he's got the root in. He's got a good tie-in on either side of the weld, so that you want to make sure that you don't have any low spots or high spots in the center. You don't want a high crown. You want to try to maintain a nice flat bead profile across, because like I said, you're building the foundation for the next passes that you're going to put in there. So now he set himself up for success on the remaining passes that he's going to put in. You're going to do one pass in there?
One pass.
Okay. So at this point, depending on how wide your root opening is, you can decide to run 2 stringer beads for your hot pass, or you can run a little bit wider of a stringer in there. So I think Sam's just going to run a little wider of a stringer. It's not necessarily a weave. Now it depends on who writes your procedure as to where you're allowed to run a weave or stringers for the remaining pass. You should have a welding procedure specification for any of the weld tests that you're going to be doing. Okay, and that should tell you your bead sequence and the type of bead that you're putting in there. I myself prefer stringers. That's just the way I've always been taught. That's what I like doing. I think stringers are a lot easier for me. We did a stringers versus weaves video that you guys can check out that shows some of the science behind that. Especially with depending on how wide the weave is, you can put a lot of heat into that plate, and it starts changing the molecular structure of the steel. Okay, and it's a weaker, not as refined grain structure in there, and it's prone to breaking. Has anybody already run this test before? Has anybody passed this test before? Good. Anybody planning on running this test? There we go. So this specific joint designation is BU2A. If you go into the pre-qualified, it's section 3 of the D11 code book. You can actually look it up. Actually, this year AWS is coming out with the 2020 version. So if you don't own a code book currently, I would wait until after the first quarter of the year to go out and purchase one. If you get the 2015 edition, it'll be obsolete by February. They'll transition into that. So he's going to go through and do his tie-in. So you can see he struck the arc about a ½ inch above the crater, then came back into it and tied in, and then you just carry on like you've never stopped. Leaving that crater in there is just going to allow you to lap that in there nice and tight to where you don't have a big lump in there, because if you get a lump at your tie-in, if you have a cold tie-in or a cold lap, that's going to carry on to the face of the weld. So the face of the weld, everything can be an 1/8 inch except for where you did that tie-in, and now you hit a little 3/16 high spot and the plate becomes rejectable at that point. And this is only a 6-inch pass. So now he went up, you can't see it because of the camera, but he went up, he's now welding on his backing strip. Okay, that's the part, that's the runoff tab, you want to weld right over top of that. Okay, I'm going to go ahead and run the root and root and hot passes for the overhead plate. So I'll just kind of walk you through the technique because he's going to be working on the trying to get that camera up and running. So I'm going to start just like this. I'm going to have about a 10-degree pull towards me. So I won't be able to see where I've been, but I can see where I'm going. So you just kind of have to trust yourself that you're going in the right direction. I'm going to stay perpendicular to this joint and just kind of do a side-to-side manipulation, tying into both of those bevels. Okay, like I said, I want a nice flat bead profile, nice and uniform, and just lay the foundation for the next set of passes that are going to go in here.
You'll see Jason started back really far on his starting plate. Again, arc starts are super important. You want to make sure you get your rod burning hot before you get into your test plate. If you start all the way at the bottom of your test strip, you should end up, so you're about done burning your rod, your first rod, you should end up somewhere in the center of your plate, and then grab a new rod and finish it out. You want to start all the way at the bottom of your test plate, because when you start your next arc, and as you stack your passes, you don't want to end up running out of room for your arc start, so you end up starting inside your testing area. Like Jason already said, you don't always have the option for power tools, so you want to make sure your root's as clean as possible. Go into it with the mentality that you're not going to be able to use power tools, and if you can, that's a good advantage. By all means, clean up your passes as you go along. Make sure everything's the same height, the same profile, and that'll make your next pass go a lot easier.
Good. All right, so I'm going to go ahead and run the hot pass.
He's going to go ahead and put his hot pass in now. You're doing a single pass weave. I'll do my root and my hot pass as one single stringer, and then my fill passes I'll do 2 stringers, and then my cap I'll do 3 stringers. You're allowed up to 5 times your rod diameter generally, but that's getting a little bit wide once you get to your cap to do that as a weave. And that all depends on your test too, on the instructor and what they allow. All right, he cleaned up his last pass, so he's going to do a tie-in now and finish off the rest of the run. Run that all the way out the end of the backer plate. Overhead, more than anything, it's critical that you keep your rod angle right, that you don't let your slag get in front of your puddle. You'll fight that the rest of the way. Vertical, gravity kind of does that for you. So the top, naturally your heat's all going to be pushing to the top. So when I get to the top, I'll kind of jump just a little bit to the top edge of the plate and then wash across, and that'll let it fill and not want to roll out. Because especially once you get more passes in there, once you start running stringers, it's going to want to dump out on you at the top edge. Yeah. Yeah, so I'll kind of, I don't know if that's proper technique or not, but I'll jump a little bit, yeah, and then jump to the top edge and kind of weave across, and that'll fill that in and it won't run out. Yeah.
So this specific plate setup and everything, you're probably looking at 5 to 7 welds that are going to be on here. Like I said, I typically do stringers, but I've known people that can run the root, the fill, hot pass, and cap in 4 passes. That's if you're going to do like a weave pattern.
Cap. 2-stringer fill and a 3-stringer cap.
Okay, so Sam's going to do a 2-stringer fill and a 3-stringer cap. That's pretty much the same thing that I'm going to do when I run my the overhead plate.
I noticed for both of you guys this your root pass, you guys did a kind of a weave or a zigzag pattern, but could you use a different technique, either circles or have a cursive E all the way up to hit on both sides of that plate instead of an actual weave?
Okay. Good question. So the method that I prefer, we'll address that one first, is just a side to side so I can make sure that I'm tying into the face of each of the bevels. Another thing you can do when I get into vertical, I like to run little horseshoes going through the side. The center's going to take care of itself, so I go pretty quick through the middle, but you got to think that root opening is only 5/16 of an inch, so I'm not traveling very far. I mentioned, anybody here for the stick basics class this morning? No? Okay, so when I was talking about that one, I operate in an area about the size of the diameter of a pencil eraser. So there's still manipulation in there, but there's not much movement. I've noticed that if you do circles or E's going up, that you're going to have a high crown in the center because you don't tend to pay enough attention to the sides. The sides is where you want to spend most of your time and energy and focus. You want to do a slight pause on the side and go quick through the center. Same principles as a weave, but because we're only operating in a small area, it's just the manipulation of a stringer. Does that answer your question? Okay. Anybody else have any questions? No? So when you run these passes, he's going to run one on the left and one on the right. Each pass should tie into the other 50%. Okay, so when you're putting those passes in, you should have 50% coverage from one pass to the other. And then when you do the 3-bead cap, or if you did a 4 or 5-bead cap, depending on the thickness of that plate, what you want to do is cover each pass on top of that 50%. So you don't want to, I get this question all the time, what if I run one on the left, one on the right, and one on the center? Don't do that. It does not test well when it goes to qualifying a procedure. You want to weld, if you're right-handed, well, put all your passes in left to right, just like you read. If you're left-handed, go right to left. Your body has a natural tendency to favor the opposite side. So if I'm right-handed, I naturally favor the left. It's just easier to point that way. If I try to point right with my right hand, it doesn't, I mean, I'm straining myself the whole time. You want to be comfortable. That's the biggest thing. No matter what position, where this is in, try to get in the most comfortable position, because if you're straining and shaking, you're going to have involuntary movement in your weld, and you're going to be able to see that once the final product is done, right? So always go right-handed people, left to right, left-handed people, right to left. Does that make sense? So he's putting his second pass in. Sam is right-handed, so he put the first one in on, yep, he's right-handed. So he put the first pass in on the left, and then he'll put the next pass in on the right. And what you can do is just slightly turn your body. So what I used to tell my students, if you've ever shot a rifle or a shotgun, you square your body up with a target where your shoulder's at. If you keep everything in line and keep all your manipulation to your wrist only. A lot of times when students or people that are just learning how to weld start off, they want to manipulate at their elbow. And so, you know, you start running that chicken wing and you get crazy, right? Anybody ever use a cane pole to go fishing? Right, you hold the bottom of the cane pole, the top of it's dancing around like this, right? The shorter you can keep that distance, the less involuntary movement you have, the more control you have over your puddle. So keep everything from the wrist forward as you're going in. And then just get into a little rhythm, like a metronome. You guys ever seen a metronome go back and forth? Get a little beat in your head and just kind of dance to that. That way everything's nice and uniform. You can do a counting, 1, 2, 1, 2, 1, 2. Do a count, or just get a little beat in your head like a metronome. So he's going to get that cleaned up. I'm going to go ahead and I'm going to run a 2-stringer fill, and then I'll let Sam talk to you guys for a little bit, and then we'll go ahead and go to cap, and then pause for questions again. Cool? Yes, sir.
On 1-inch plate, what about the use of dog ears?
Yes. So he's saying dog ears like strong backs. So strong backs is essentially just another piece of material. I don't want to move that. The camera's sitting on top of the plate. I don't want to move it. So on the back, it's just like a rectangle with a hole punched in the center, and you weld that on either side of the on either side of the backing strip. And what that does, that prevents that plate from curling up. So especially on 1-inch plate, because that thing will turn into a banana, because there's about 20 to 25 passes that you're going to put in that area. Same root opening, about 5/16, 22.5-degree bevel on each plate. It's going to start to curl up. Heat's going to move metal. Okay, and there's nothing you can do to stop it. You can put the dog ears on there, or strong backs as we call them. What that's going to do is that's going to keep the plate as flat as possible, because I don't want that plate to curl, especially if I'm going to do a bend test. Because once I cut that piece up, now I have to at least bend it flat, and then I have to bend it an additional 180 degrees. So I want to keep that plate as flat as possible. 3/8, typically you don't have to worry about it. It's going to curve up a little bit, but not much. Any other questions? All right. Just side note really quick. So Sam and I were bouncing back and forth. I didn't turn.
It was warm.
Okay, it was a little warm for him. So the class that we did this morning, I discussed finding the appropriate amperage for the welding rod that you're going to be using. So with an 1/8-inch rod, I can use the decimal equivalent. So it's actually 125 thousandths of an inch, or 0.125. Just grab your calculator, hit 1 for 1/8, divided by 8, and that'll give you 0.125. 125 amps is a good place to start in the flat position. Okay, once I get into vertical, reduce that by 10%. So take your 125, multiply it by 10, and you'll come up with about 112. Same thing with overhead. I'm going to drop that by about 5%. So if I take that 125, multiply that by 0.95, that gives me about 117 amps, somewhere in there. So I'm going to run about 118 overhead. And this works because it sounds like you do a lot of 1-inch plate. This works just as good on 1-inch plate as it does on 3/8. It's the amperage capacity of the rod, not the thickness of the material, because that material is beveled. So each pass that I'm putting in, I'm not welding on 3/8 plate. It's getting a little bit thicker as I go, and I'm just putting single passes in the whole time.
Jason's going to go ahead and run a 2-bead fill again, and just like I did. And he's going to put his first pass on the left, second pass on the right, 50% overlap. The little bit of extra amperage helps on your overhead test, keeps the slag out. Vertical, slag's going to pull itself out, it's going to want to run downhill, and if you're running too hot, naturally the weld's going to want to run out on you. As far as I know, most of the tests don't have a time limit, so if you can give it some time in between passes to cool down, that helps a lot too. Take advantage, if you're doing the test, take advantage of everything you can. They talked about ESAB's new prime rods. If you guys haven't seen those, they're 4-pound, I believe, vacuum packed rods. I don't know what they did, but the deposition rate on them is awesome. And smooth restarts. I've burned a couple packs of them so far, and I'm super impressed with them. All ESAB's electrodes are always good, but the primes are really something else. You can get your hands on them. He's going to finish putting his second fill pass in and get that cleaned up, and then I'll put all my cap passes on. I'm going to start from left to right, overlapping approximately 50%. One thing you want to watch, at least when I do it, I'll angle my rod towards where I start just a little bit, so I'm not undercutting the edge of the toe of the bevel. You're allowed very, very small amount of undercut, if any. It's been quite a while since I've done a test myself, but you don't want any undercut if possible. So I find angling my rod that way, if I'm left to right, at least for the first pass, seems to help preventing any undercut.
Yep. So one thing I like to do on my fill passes, once I'm done with my fill passes, I want to make sure that that fill pass is roughly 1/16 below the finish of that surface, because if I can keep that pass a 1/16 below on both sides, I have more than enough space to lay my cover passes in there without exceeding that 1/8 cap that I'm allowed to have. Like I said, 3/8 plate, you're allowed 1/8 weld reinforcement, and that's the distance from the top of the plate to the top of the weld, and that's throughout. If any spot is higher than 1/8, it's rejectable, okay? So you don't want to run into that situation. Everything looks nice and good, and you got one little spot, you got a high lump in there, it becomes rejectable at that point. So if you keep both of those passes a 1/16 below, and just watch as you're in your hood, you can kind of look as you're going in and just flow that puddle right over, and just keep it just below that piece there. Another thing, when you go to put your cap passes on, one thing you can do, and there's nothing in the code book against it, I can draw a line an 1/8 inch to the left or right side of that weld, and that just gives me a good visual representation of where I want to run the sides of my puddle into, okay? Especially on that first pass that you put in there, because a lot of times it's really easy once you lose those kind of like bumpers, like for bowling. Once you lose that groove, you can go off the plate really quick if you're focused on that little puddle and you're not paying attention to where everything else is laying. That little soapstone or scribe mark, that just gives you a good indication where to line that left side of your puddle up to. All right, so Sam's going to go ahead and put in pass number 1 of his 3-bead cap, starting on the left-hand side, and I point right over to the left. I'm probably, so If you're straight in 90 degrees to it, by 10 to 15 degrees, point the tip of that electrode to the left, okay, and it'll practically lay itself in. Do a little bit of oscillation with a vertical progression, just kind of side to side, just like a little horseshoe. Like I said, very small manipulation. So if you notice, if you ever open up the inside of your stinger, right, you see it's got little jaws in there. There's little marks. Okay, those hold the electrode in a very specific spot. So I tell people, if you're going to do vertical, you're just starting off to do vertical, put it in that angled spot right there. And then if I extend my hand like I'm going to shake somebody's hand, hold that stinger just like that, and it holds you at the perfect angle to run vertical. Okay, I want the back end of this rod, where it's sitting in my stinger, 1 inch lower than the tip at all times. Okay, a lot of people, they start going down too far or going straight in. I want to try to push that puddle up. So if I don't have that rod situated just right, I can get weld buildup behind that rod as I progress up. Okay, and that's not going to be very good for that cap pass. So just hold your hand out like you're going to shake somebody's hand with that angled position in there, and just kind of be mindful of keeping the back end of the rod roughly 1 inch lower than the front at all times. And that's about all of the work angle you need to have on there. Same thing with overhead. With overhead, I just put those same jaws, put it straight in the top, and I just pull my hand back just a little bit. 10 to 15 degree drag angle as I'm pulling through. You always want to get that first pass on the left-hand side as you're working, especially if you're right-handed. Now, if you're left-handed, you're going to want to you're concentrating on the right-hand side. You want to make sure that first pass is in there nice and tight. That second pass and that third pass, you're just going to tie it into the previous weld. So I use that toe, or the right-hand side of that previous weld, as the center line of my next pass. Okay, by doing that, 50% of that weld puddle is automatically going to end up on that previous weld. So game over, right? I point, a little bit of manipulation, watch that puddle roll over, keep the rod kind of centered on the toe of that previous weld, and everything will lap together. Third pass, same thing, and then you're done. Now once you do a 1 inch plate, you're probably looking at 5 to 7 passes for the cap, unless you run 2 to 3 small weaves across the top. But usually 5 to 7 passes, you get that first one in there, the other two will lay right, just lay it right next to it, side by side, and you're done. One good thing if you're practicing, so the welding instructors out here, take a 6 inch by 6 inch piece of 3/8 plate, have the student lay it flat, weld one single pass right on the edge. Stand it up in the booth and have them just pad beads. Can't screw that up. Ray Charles can weld that up at that point, right? He's got little places to go off of. But then after that, the cap is the hardest part, right? Because they can't seem to get that cap right. They go too far to the right. Next thing you know, there's a split between the two welds. Just weld it on the toe of that previous pass, and it just gives you a nice little visual where you're supposed to be on it. You got one? What do you got left? One more? All right. He's going to go ahead and tie his last pass in on the right-hand side, pointing to the left, pointing to that second pass, and just use the previous toe. And this is going to seal up. I usually try to stay within a 1/16 to an 1/8 inch of that where that bevel is, the top of that bevel. Stay to a 1/16 to an 1/8 inch on the left and right side with that cap pass, and that's always enough to tie it in. Now, if you guys are going to do this for a bend test, you can flame cut the back. You can grind them off, or you can machine them off. Whatever's easiest for you. I've found that a scarfing tip, or some people call it a weld washer, depending on where you're at on the torch, those do really good. Easiest thing you can do is cut the test strips out and then take the backing strip off. That way you're only removing 3 inches of material versus that whole 9-inch backing strip. Now, we've actually also done videos on this on the weld.com channel, so if you have time, check those out. I go through a full breakdown on the screen on how to set your amperage. It's any diameter, any position for 7018 electrodes. That's what we're using here. That's another thing, you want to make sure you have dry electrodes. But we go through how to figure out the decimal equivalent, the 90% rule, the 95% rule, and then we go through and test them all out, just to kind of show you that it actually works. And then we run a couple 3G and 4G vertical and overhead tests. Oh, the slag's peeling back. So anytime your slag peels back, that tells me that I have bad welding rods. No, I'm kidding. So if you have slag coming back, that means that I don't have any weld discontinuities or surface discontinuities for that slag to stick to. So if that stuff's rolling off, it's a very good indication that I don't have porosity in there, I don't have undercut or anything like that. Everything's uniform and smooth, has less surface area to stick to, and it just peels right off.
Jason's going to go ahead and do the same thing. Stack his passes, 3-pass cap, left to right. Like I said, angle your rod a little bit that way. It'll keep it from undercutting. Your last pass, you're going to want to spend a little bit more time there to make sure you're filling all that in properly. That'll take a little bit longer to fill that in. Just make sure you spend enough time there that you don't end up with undercut or not enough fill, because those will get ground smooth for a bend test, and if you're not full enough, it's not going to pass. That's a perfect example of what a runoff strip is for. Yep. I do a slight weave on my cap passes. Make sure you have 50% overlap onto your side plate and onto the previous weld, and follow that across. And just a slight back and forth motion is enough for me to make sure I have everything filled in the whole way across. Let me turn you up. That might have been my fault. I didn't turn you back up. I said that might have been my fault. I didn't turn you back up. You want it back up? All right. I was making Jason look bad there. I didn't turn him back up.
No, it's running pretty good. All right, so one thing we forgot to mention is when you guys are doing these plates, your run-on and run-off tabs, those are parts that people often, you know, they neglect those areas. Make sure to clean those up. I often refer to that as, anybody own a dog? You let your dog out, he craps in the front yard, you're walking in from work, next thing you know, you're dragging it through the house, right? It's the same thing, okay? If I have a bunch of slag or buildup or anything like that at the start of the weld, and I strike an arc, now that stuff's in my weld pool. Where am I going with that? All the way through my test plate. So always make sure to check out the start and the starts, stops, and the end passes. Make sure all that dirt, debris, slag, anything like that is all cleaned out, okay? We'll go ahead and break these free. We'll probably leave them up here as long as you guys don't touch them. You can come up and take a look at them. I don't think the floor is appropriate. We'll find something so you guys can come up and take a look at them. Does anybody have any questions, comments, concerns before we conclude? All right. Thank you guys for coming out. If you have any questions that you don't want to ask in front of a live studio audience, feel free. Sam and I will be up here for a little bit if you guys want to pick our brains. Any questions, resources, especially the welding instructors, students, if you guys have questions on any of this stuff, hit me up on Instagram at redbeardwelds, and I'll be more than happy to give you any information that I can, help. I'll point you in the right direction. Sam, same way, Sam Welds, right? Sam Welds. On Instagram. So thank you guys, appreciate it. Everybody thank ESAB for allowing us to run ESAB University here. I hope you guys learned something. Enjoy the rest of FABTECH. Yes, sir.